Hey everyone, I'm going to talk about high pressure pump that I used in modeling my diesel engine. Let's see that together. That's it that I modeled. Okay. Let's move on to high pressure pump, and after that I will introduce this or explain this pump for you, modeling this pump. Okay, as you can see, one type of injection pump is the inline pump and another type is the rotary pump. Okay. The main function of injection pump, which is part of the high pressure circuit, is to deliver fuel under high pressure to the injectors. Yeah. And the injection pump is essentially the heart of diesel engine. Generally, there are two main types of injection pumps. It is one of the most crucial components of the fuel supply system. The main function of this pump is to increase the fuel pressure from around 5 bar to the required pressure for the injection and opening of the injectors, which can range from 200 to 2000 bar depending on the engine type. Most injection pumps are of the piston type. Okay. The high pressure pump used in the engine under a study is of the rotary or distributor type. Okay, as you can see in this picture, this pump consists of the following components. Fuel inlet from the low pressure pump, outlet to the tank, outlet to the high pressure rail, and pressure regulator. Based on the type of pump used in the engine under study, as I said, a rotary or distributor, fuel pump has been modeled in the GT Suite or GT Power software. Okay, let's see the pump that I modeled in GT Power. That's it. And as you can see, the component of the model in question are fuel inlet to the pump, pump outlet to the fuel rail, outlet to the pressure regulator, and the pump assembly 1, 2, 3. Yeah, pump number 1, number 2, and number 3. This is my pump, yeah, that I designed in GT Suite software. A structure of the model in GT Power are piston, a spring, and mass. Yeah. Piston represents the reciprocating mechanism of the pump. In GT Power, it is modeled using a part such as a reciprocating mass or a user-defined piston. Its movement is typically coupled with the rotation of camshaft or controlled via a specific condition in Simulink or GTSE. As you can see, we have 3 cam here, and after that camshaft, mass, piston, yeah. A spring used to return the piston to its original position after pressure discharge. Modeled in GT Power using a spring element. It typically simulates the system's elasticity defined by a spring stiffness and initial position. And mass represents the inertia of the mechanical system, such as the piston mass or parts of the pump's internal mechanism. It helps model pressure fluctuations and mechanical vibrations. Usually define the mass as a mass component or considered within the reciprocating assembly. Okay, to better understand the operation of each of three pumps used in this high pressure pump, let's go through one of them. Yeah. That's it. In this figure, fuel is drawn in from the filter through a one-way valve by the suction action of the pump and enters the compression chamber. Yep. Then the cam pushes the piston downward, closing the fuel inlet valve and opening the outlet valve, which operates oppositely to the inlet valve. Yeah, the pressurized fuel then flows through the outlet valve, moving toward the outlet and exerting increased pressure on the piston. Based on this explanation, I analyzed one of the fuel pumps model in GT Suite to provide clear understanding. Okay. And in GT Power, this is my high pressure pump, and this is model of engine that I designed in GT Power. Okay, and that's this pump.